Fault in a barometric pressure sensor or circuit may cause the engine to run rough and use excessive amounts of fuel. This is why it's important to understand the operation and testing procedures of these sensors. In this module, we'll be covering the barometric pressure sensor. We'll check out signal voltage high and low DTCs and the processes needed to rectify them. The baro sensor is a component used in conjunction with a mass airflow meter or manifold absolute pressure sensor. This sensor provides the engine control module detailed altitude and atmospheric pressure data for a more precise fuel delivery. So, how does it work? The baro sensor uses a strain gauge pressure detection method. A piezo-resistive element alters its resistance value as stress is applied. This element is attached to the diaphragm of the pressure sensor. The piezo element uses a Wheatstone bridge and amplifier circuit for a usable signal output. For more information on these devices, please watch our video on piezo-resistive sensors. These are 3-wire sensors, supplied with a high and low reference voltage. It then generates a signal based on atmospheric pressure. The sensor's purpose is to continuously monitor the atmospheric pressure, so the ECM can optimise fuel delivery at all altitudes. The higher the altitude, the thinner the air, so adjustments need to be made to protect the engine from excessively rich mixtures at these heights. The MAF or MAP sensor alone can't sense the increase or decrease in altitude. Therefore, a baro sensor is used. Just like all other pressure sensors, a fault in the baro circuit will set codes in the ECM. Looking at the trouble code table, we can see that voltage high, low, excess resistance, and signal performance-based codes may be set. But if any other fault codes should set, such as ones relating to the intake air temp, airflow meter, or manifold pressure sensor, they should be addressed first. Here are the steps needed to successfully diagnose a barometric pressure circuit fault. We may need to remove the sensor and inspect for contaminants or blockages. Ensure the sensor isn't damaged in any way. If this is okay, we can now test the integrity of the circuit and sensor. With a scan tool, check the desired and actual baro readings and ensure they are identical. This is a correct value at sea level. If fitted, confirm the MAP and baro sensor values are the same with the ignition on. Start the engine and the MAP sensor values should reduce as it's now under vacuum. It's great practice to confirm the readings with an altitude versus barometric pressure table. This vehicle has a baro sensor designed as part of the multifunction intake air sensor. Other OEMs may choose to install theirs in different locations, but their tests are identical. With the ignition off, disconnect the multifunction intake air sensor. With the ignition back on and the meter set to volts, place the black test lead on the low reference terminal in the harness connector and the red on the high reference terminal. Between 4.8 and 5.2 volts should be displayed. Move the black lead from the low reference terminal to the signal terminal. Again, 4.8 to 5.2 volts should be seen. If the correct voltage was present during each test, we have proved the circuit's integrity, leaving the baro sensor as the cause of the fault. But what if we didn't get these values during our test? Let's see what we need to do if the voltage readings were incorrect. With the sensor disconnected and the ignition on, place the black lead on a known ground and the red probe connected to the high reference terminal in the harness connector. If the meter displayed over 5.2 volts, this confirms a short to voltage within the circuit. Turn the ignition off and disconnect the ECM. Turn the ignition back on while watching the meter. If voltage is still present, this confirms a short to voltage within the harness. But if the meter dropped to 0, then the short to voltage could be in the ECM or a circuit from the ECM. To eliminate the ECM as the fault, perform a continuity test between the high reference terminal and all other terminals in the ECM connector. If no fault is found, the short to voltage will be in the ECM. If while testing the high reference circuit, the meter displayed less than 4.8 volts, this might indicate a short to ground. With the ignition still on, connect the red lead to battery positive and the black to the high reference terminal. Any voltage now displayed on the meter confirms a short to ground within the circuit. Turn the ignition off and disconnect the ECM harness connector. Turn the ignition back on and observe the meter display. If voltage is still present, this confirms the short to ground is within the harness. However, if the meter dropped to zero, then the short to ground may be within the ECM or a circuit from the ECM. To differentiate between the two, perform a continuity test between the high reference terminal and all other terminals in the ECM connector. If no fault is found, the short to ground is within the ECM. Connect the meter between the signal terminal in the harness connector and chassis ground. Turn the ignition on and observe the display. Again, on a pull-down circuit, we should see 0 volts. If there was anything other than this, there may be a short to voltage within the circuit. Turn the ignition off and disconnect the ECM harness connector. Turn the ignition back on while observing the screen. If the meter displays 0 volts, the short could be within the ECM or a circuit from the ECM. To differentiate, turn the ignition off and perform a continuity test between the signal terminal and all other terminals within the ECM connector. If no fault was found, the short to voltage is within the module. But if when disconnecting the ECM, the meter reading remained high, then the fault will be within the wiring harness. With the ignition turned off, disconnect the Baro sensor harness and ECM connectors. Place the red lead on battery positive and the black to the signal terminal. Turn the ignition on. The meter should display 0 volts. Anything other than this will indicate a short to ground within the wiring harness. To rule out a short to another circuit, perform a continuity test between the signal terminal and all other terminals in the ECM connector. If no fault is found, the short will be in the ECM. Barometric pressure sensors play an important role for correct engine operation and reduced emissions. It's vital to understand how they work and how to test for a successful diagnosis. So, keep an eye out for signal performance and signal erratic training modules in this series. Thanks for watching. See you soon.